In this example, I want to show you how to simplify radical expressions. So I have two examples here to share with you. In part A, we have a radical with index 3, and in part B, we have a radical with index 4. So in part A, since we have an index of 3, what we want to do is factor the quantity inside of this radical as perfect cubes as much as we can. We may have some leftovers, but we want to factor out these values as much as we can into perfect cubes because of the index 3. So again, I'm going to work my steps vertically down the page, equal sign between each step because I'm getting something that's equivalent to this each time. So inside of this radical, so do not lose that, do not drop it, it is still there. So negative 125 is negative 5 cubed. Okay, again, notice the use of parentheses, really important. It's negative 5 times negative 5 times negative 5, which gets you this number right here. And then x to the 12th is x cubed times x cubed times x cubed times x cubed. Right? And if you use properties of exponents, you could combine all these factors together to get x to the 12th. Looks like I need to extend my radical a little bit further. Y to the 9th is y cubed times y cubed times y cubed. So you can see here that actually everything factors into a perfect cube. So now what's going to happen is all these exponents of 3 are going to cancel with this radical of index 3. And I'm left with negative 5 times 4 x's and 3 y's. And we definitely have a much more efficient way of writing such an expression. This is negative 5 x to the 4th y cubed. Great. Okay, so in the second example, because the index is 4, I'm now wanting to factor each of these values here into something to the 4th power. So again, working down the page, keep the radical with the index. We're just working inside. So 16 I know is 2 to the 4th power. X to the 12th, x to the 4th, that's 4 of the x's, x to the 4th, that's now 8 of the 12, x to the 4th, that's now all 12 of the 12. Extend these out. Y to the 8th, we've got 4 of those y's and 4 more of those y's. So again, this takes care of every term. However, if this had been y to the 9th, I would have an extra y over here. Sorry. So all of these bases here that have an exponent of 4 will cancel out with this radical of index 4. If I had any extra terms lying around, like a y to the 1st power, that would stay inside this radical. So we're going to have 1, 2, 3 x's, 2 y's, and a 2 in the denominator. Again, I can write this in a much more efficient way as x cubed y squared over 2, and that's my final answer.